Now, these are the packet types you will find if you sniff the link between two routers that runs EIGRP. Every 5 seconds, you will see each device sending hello packets. And if there is any networks added to EIGRP, you will see update. And you remember I was telling you in the topology table, we have both primary and the backup path, successor and the, what's the word for backup path?
Sorry, sir, I forgot.
Starts with F. Successor and feasible successor.
Yeah, feasible success. Yeah.
Feasible successor is what we call this backup path. Now, when there is no feasible successor, you remember we saw there is something called feasibility condition.
Yes.
When the condition is not met, then the path which is available cannot be used as the alternate path because the feasibility condition is not met. Then when the primary path goes down, what will happen is the router will start querying for a path.
Yes.
That's what query. Asking the neighbor about some route information which is lost. See, we had a primary route. We did not have any backup route. When the primary route goes off, it will start querying the neighbors for the alternate path. If topology table don't have it. So query comes into picture only when the backup is unavailable and primary has gone down. Primary route has gone bad. Now for the query, the response comes. So one of the neighbor may have some backup information, route information. They give the response as a reply to the query. That's what we call as a reply packet. And then the acknowledgement packet. For any update, the update will always follow by acknowledgement, meaning whoever receives the update should acknowledge by sending I received it. So the sender gets an acknowledgement. Not only that, if someone queries, and when my router receives, when this router receives query, this router will say, I got your query. That's to acknowledge that I received your query, I'm working on it. And when this router replies, the one who receives the reply, the queried router, the router which sent the query, when it receives the reply, it should say, I received your reply as an acknowledgement. So, in short, what I'm saying is, for update, query, and reply, there is an acknowledgement. Will there be any acknowledgement for hello packets? No. Why? Hello packet itself is an acknowledgement. Every 5 seconds, it comes and acknowledges that the neighbor is available, still available, alive. Hello is sent every 5 seconds. If we expect a acknowledgement, then it becomes too much traffic. Hello, and every 5 seconds for the hello you send acknowledgement. That's not a right approach. So there's no acknowledgement for hello. For other three packet types of EIGRP, you have acknowledgement. Now, here we see how these packets are sent and received in between two routers, especially during those initial discovery time. Let's say router A is configured first and followed by B is configured. So router A is saying, I am router A, meaning the IP address of the router, the exit interface IP address of the router. And it is saying, I'm A, is anyone there on the link? Who is on the link? That's the hello packet. And B gets a turn to say hello. It says, hello, I am B, and this is my route information that I have. So that goes as an update. Now, the hello from A is a multicast, but the hello from B is an unicast because B already learned about A. Because B has already learned about A, it can send the complete routing information. See, when A was sending hello, it was not sending update along with hello because A did not learn B. It's the first initiation happened between A and B. A is the one initiated. So because they don't know who is connected on the other side, it is simply sending hello, no updates. Whereas B, it knows very well that I'm connected to A on this link. So it says my name is B, means my name is, let's say, 192.168.1.2. That's my IP address on the exit interface. And this is what I already learned from other neighbors. So now two things happens in A. One, A has learned B, and A is also updating its topology table with the update that it received from B. And also it is sending an acknowledgement to B saying, I received your routing information update that you gave, right? And then followed by A also sends its own update as a unicast to B, for which B is going to send an acknowledgement. And receiving this update, B will update its topology table. After this, the dual algorithm comes and picks the best path, puts the best path into the routing table. Actually speaking, the updates are being processed by the dual algorithm, and then only it gets into the topology table and the routing table. It is not like update comes and sits in the topology table and the dual algorithm comes and processes it. No, that's not the real story. In OSPF, it happens like that. In OSPF, it collects all the link state update. Link state database gets synced with the neighbor, and then only SPF comes and picks the shortest path. In EIGRP, it's slightly different. When a router receives an update, that update is being received by a dual algorithm, and dual algorithm decides the primary and the backup, the successor and the feasible successor. Only those elected successor and feasible successor will be entering into the topology table. If an update is not meeting the feasibility condition, then it cannot enter into topology table. Now, from the topology table, you can see two things. One is successor and the feasible successor. Whereas in the routing table, you will find only the successor. Now, when you talk about metric of EIGRP, it's same like IGRP metric. Both EIGRP and IGRP have the same metric because it is developed by the same Cisco. EIGRP is actually a um, advanced version of IGRP. So the metric is same. The metric of EIGRP, bandwidth and delay, sorry, not reliability, delay. IGRP also bandwidth and delay. And these three are not considered. Reliability, load, and MTU. Optionally, you can enable them if you want. But by default, to avoid complexity, only bandwidth and delay is focused. Only bandwidth and delay is focused. Now, what is wrong in focusing on reliability and load and MTU? Whenever there is a load, the reliability decreases. They're inversely proportional. And the load on a path will always keep changing. If you take any road that connects to airport, the traffic towards airport, again, it depends on the airport. If it is international and domestic in the same airport, the traffic will be always there, even in the midnight. You can expect the same, almost average, same amount of traffic 24/7. The load is same always in that. So reliability of the road is also same. But if you take the road that connects to the market or MNCs, you will find the peak hours, maybe from morning 7:30 till 10:30 in the morning. Again, the load will be less because everyone has already reached the market, everyone has reached the office, school. The load on the path is less after 11:30. Again, somewhere around 3:30, the load increases and reliability on the road decreases. Maybe till 9 p.m. in the evening. But the road bandwidth is always the same. The size of the road, the breadth of the road is always same. If it is 80 feet road, it is 80 feet. In the peak time, in the other non-peak hours, the bandwidth is always the same. When the road is narrow, the bandwidth is same every time, even if it is narrow. But the delay is not the same. The broad road and the narrow road. In the narrow road, delay is X. In the broad road, delay will be Y. And that Y will be always there. It won't go less than that, it will be always above that. For example, even the road is broad, how much ever it may be broad, the time taken to go 20 kilometer is going to be always at least 10 minutes. 10 minutes. The delay will be always 10 minutes. You cannot go less than that. It may go 10 minutes to 20 minutes, but it will not come less than 10 minutes. That's the expected practical time to reach 20 kilometers. So the bandwidth and delay are constant. For a road, for a 100 feet road, what is the bandwidth? 100 feet, always 100 feet. It's a constant. For 10 kilometer, what is the delay? That's a constant value. But the load and reliability is not constant. Time to time the load changes, the reliability also changes. In the midnight you say this road is the best road because there is no traffic. The same road the next morning you say, oh, what a worst road it is. Inch by inch the vehicles move. Very bad road. But in the night you praised, but in the morning you hate. Because the load is not the same. So the reliability changed now. In the night it was very reliable road. But in the morning the reliability is gone. You cannot trust the road for emergency. We need a helicopter now. So whatever we are seeing here is very important point to understand why reliability and load is not considered. They keep changing the variables. Now, if we consider this variable thing, whenever this changes, the routing will also change. The path will also change. If paths keep on getting changed, it's not good. If path for a destination is just jumping from east to west and west to north and north to south and north south to east, if it is simply changing different gateway, then there will be an ARP issue, there will be discovery of line protocols, a lot of things will be a problem. Keep on changing the direction and the path is not good. So reliability and load is not considered. The MTU is also a constant, like bandwidth is constant, delay is constant. MTU is also another constant. But because we already have two constants considered, uh, they don't want to consider another constant value. But again, I'm telling you, if you want any of this, you can make EIGRP to consider. There is a command called metric weight, metric hyphen weight. You go under router EIGRP and say metric hyphen weight, and then you change these things. It's possible. You can go and add the K values. We call this K values. The K doesn't mean here anything. K is the alphabet that is used in the algorithm. K1 means bandwidth. K2 means load. This is K1. This is K2. K3 is delay. K4 is reliability. K5 is MTU. This is the order. Here the order is not, this is not in order. This is the order. K1, K2, K3. So it should be bandwidth first, and then load, and then delay, and then reliability, and then MTU. This is how it should be. In which the first and the third one, the bandwidth and the delay, K1 and K3 is considered. These two are considered. And this
Yes.
K2 will be there in the algorithm. K4 will be there in the algorithm. K5 will be there in the algorithm, but they're all multiplied by 0. Anything multiplied by 0 is 0 only. So if you multiply MTU 1500 by 0, it is 0. If reliability is 10 and you multiply 10 with 0, it's going to be 0. And if the bandwidth is 100 meg, if you multiply bandwidth by 1, then you get 100, which means bandwidth is considered. 100 multiplied by 1 is 100. It's not 0. Delay multiplied by 1 is delay. It is not 0. Next is, when you compare the metric, there is a slight variation in the number of bits involved in calculating the metric. IGRP uses only 24 bit. EIGRP uses additional 8 bit, which is 32 bit. If IGRP metric is 1, what is EIGRP metric? 256. Because you need to multiply this by 2 to the power of 8. 2 to the power of 8 because you have 8 bits extra.
Yes, sir.
Now, I was telling you earlier, the metric of EIGRP, you need to know only this line. Because now we consider only bandwidth and delay. We don't consider K2, we don't consider K4 and K5. It's only bandwidth and delay considered. So the formula is, the metric of EIGRP is slowest link bandwidth plus sum of delay. What does this mean? You see in the next page. Between A to D, which is the slowest link via this B path? Via this B path, this is the slowest link. What
Yes,
is
sir.
T1? T1 is 1500 kilobits. That is T1. In another word, you can write 1.5 meg. 1.5 meg is bigger than 64 kb. So the slowest link is between C and D. That is why 64 kbps is taken as the bandwidth in this path. Plus sum of means addition of all the delays. So in order to reach this network, let's say 2.2.2.2 from 1.1.1.1, from 1.1.1.1 to reach this 2.2.2.2 via B and C, this is the bandwidth that will be considered and this is the delay that will be considered. On the other path via XYZ, the bandwidth is same on all the links, so 256 is going to be the bandwidth and the delay will be the sum of delay. Delay is the sum of all delays of all links along the path. And delay is equal to delay in tens of microsecond multiplied by 256. Again, these things are not needed. This is how internally it is calculating. Bandwidth is the lowest bandwidth of the link along the path. Bandwidth is equal to 10 to the power of 7 divided by the bandwidth in kilobits multiplied by 256. Again, I'm telling you, these are all not important. The metric of EIGRP, this line, slowest link bandwidth plus sum of delay is what we need to know. We don't need to know this 10 to the power of 7, that's what you saw here. It's the same thing. Not necessary. As I was telling earlier, this IGRP is no way useful now to learn because no one uses IGRP. Now today's routers don't support IGRP. You don't have an option to enable IGRP. The only protocol that you have now is EIGRP. I mean, IGRP or EIGRP, it's only EIGRP. We do have all protocols like OSPF, but among these two, only EIGRP is available now. IGRP is no more, but still, nothing wrong to learn the comparison. As I said, this is only 24-bit length, and this is 32-bit length. So in IGRP, if it is 1000 as a metric, 256 times more is what EIGRP. So you multiply this by 56. because the 8-bit extra. Likewise, if you have 512 as the metric of EIGRP, you need to divide by 256, which is going to be 2000 IGRP metric. So here what they say is both IGRP and EIGRP are backward compatible, meaning we no need to redistribute the routes. If both EIGRP and IGRP are in same autonomous system, the routes are EIGRP will be given automatically to IGRP, and IGRP routes will be given automatically to EIGRP. They will understand each other because the metric is same, bandwidth and delay. All right, and this calculation you no need to do. This also happens automatically because Cisco's protocol, both are Cisco, same protocol, they are compatible. Again, this is just for a knowledge, not necessary, because you will not see such environment. When will you get this scenario? If you have a very old router that only have got IGRP, and you got a very new router which has got only EIGRP, and you got a moderate router which supports both IGRP and EIGRP. Very rare case, you will not see this scenario.
Yes, sir.
Right, so this chapter was about the important features that you have in EIGRP, what it is and how it is different from other protocol. We learned a successor, feasible successor, advertised distance, feasible distance, topology table will have both successor and feasible successor route. Routing table will have only the successor routes. The metric of EIGRP, the metric of IGRP, the variation in the number of bits, the compatibility between the protocol EIGRP and IGRP, etc. So in the next chapter, we'll be dealing